Welcome back, everyone. Let's test your new skills with k-nearest neighbors with Python. So we're going to test your new skills on a real data set. And essentially what we're going to be doing is analyzing sonar frequencies to help distinguish between rocks or sea mines. Let's head over to the notebook, have a quick overview, and in the next lecture, we'll go over the solutions. All right, here we are at the exercise notebook. Due to the simplicity of k-nearest neighbors in general, what we're really focusing this project on is just you remembering how to set up a pipeline and use that grid search cross-validation tool. Those are especially good skills to know because they can be generalized for any model, not just k-nearest neighbors. As we mentioned, we're working with sonar data, and essentially sonar sends out sound waves, and as they propagate through the water, what we do is we detect what kind of sound waves come back. Essentially, there's a signal strength per frequency of sound. You can imagine we can send low frequency notes or high frequency notes. And so what we do is we send out the sonar signal and then detect what comes back. And this data set contains response metrics for 60 separate sonar frequencies. And what we do is we send them out to a known minefield that was already set up, and we also know that there's some objects there, like rocks, that are not actually mines. And the main goal is to create a machine learning model capable of detecting the difference between a rock or a mine based off the response to these 60 separate sonar frequencies. And you can check out the data source link right here in case you want more information about where this data comes from. But essentially what we're going to do is run these cells to load up the data, and you'll notice we essentially have a signal strength per frequency. So there's frequency 1, 2, 3, etc. And what you're going to do is treat these frequencies as if they were features. So you have 60 frequencies, or 60 features, so to speak, and then you have a label, which is either R for rock or M for mine. Then you'll go ahead and do some data exploration to see how correlated these actual frequencies are. Since there's 60 frequencies, there's not really too much to visualize here. So we really just ask you to just focus on this heat map, figure it out, and then after that, we head straight to the train test split. So you have your classic tasks here, train test split, and then we want you to create a pipeline using both the standard scalar and KNN model, and then perform a grid search to check a various range of k values. You can see we checked from 1 to 30 for k nearest neighbors. And then after that, you have this kind of hard bonus task, which is using this CV results dictionary off the grid search CV object. See if you can create a plot that looks something like this. It's plotting out the mean accuracy for those cross validations versus the k value used. Then, for the final model evaluation, you'll go ahead and use that grid classifier, that grid search CV, to create this confusion matrix as well as print out a classification report on the final test set, which is mines versus rocks. All right, so you can see we're getting a performance here of around 90% accuracy. It's a pretty balanced data set, 92% recall-ish and 88% precision, so not too bad. Hopefully you can achieve good results as well. We'll see you at the next lecture where we go over the solutions.